G'day viewers, Alan here. Welcome to my workshop. I'm back in it after a very pleasant holiday. My wife of 47 years decided that she'd like to go away in the caravan with me for a week, and I thought, well, I'm not going to say no to that. We had a great time. Anyway, back to my Lynx 15 project. What I want to do now is get the cylinder liner installed and then make the piston and the gudgeon pin or wrist pin, and that should complete the bottom end of the engine. So I'm going to get straight into it. So I'm preparing the cylinder sleeve or liner for insertion into the cylinder block. When you last saw this, it was straight off the lathe, and so now what I'm doing is cleaning the bore up to be close to a mirror finish for the Viton or rubber O-ring. Now what I'm going to do is attack it with some diamond lapping paste. So I've made up this lap. This is the same as I did it for the Webster engine. There's plenty of stuff on the internet about how to do all that. But the idea is you put it in there. Oh, I need to adjust this to size. Anyway, and then put the diamond lapping stuff on there and run this backwards and forwards inside. So I'm going to be over to the lathe to do that. Alright, well, I've just spent several hours trying to get the surface finish in this thing a lot better, and I think all I've managed to achieve, in spite of using a hone and also a diamond lap, I think I've basically managed to polish the high spots without addressing the underlying surface finish. Now the drawing actually calls out for this to be made from mild steel, but I had a scrap of 4140 which was the right size, so I decided to use that. Now, I didn't have any trouble getting a really good surface finish on the outside, but as you saw, the inside left quite a bit to be desired. So I've given up on the attempts to clean that up, and I've made another one out of mild steel, some free cutting steel, I forget what its code is, and this is straight off the lathe. I haven't done anything to it yet, and I think you can see I'm starting from a much better position. I don't know whether I can put them side by side, whether that works or not. Maybe. Anyway, so I've now got to repeat all that lapping and see if I can get a better go here. Actually, this one feels pretty darn good, just as it is. It feels very smooth to the face of your finger, but it also, there's a very, very slight roughness to the back of the fingernail. So I think this will clean up pretty well with the diamond lap. So let's give that a go. Okay, so this is what I've finished up with. It's certainly not a mirror finish. It's probably not on the same planet as a mirror finish, but at least it's in the same galaxy, I think. So that's going to be what it's going to be. Just for a comparison, this was Mark 1. Nice shiny high spots, but a long way from being what I was looking for. So there we go. Time to install this in the cylinder, into the, this is the liner. It's time to install it into the cylinder. I'm going to use a combination of heat and pressure, and I did an experiment earlier on and warmed this up, and even with, I think, a relatively modest warming, that was looking like it would just drop in. This is the dud that I'm not using, and here's the one I'm going to use. Now, why are they both here? I'm going to smarm this one up with the old Loctite, and use this one as a size gauge. When it's loose in the bore, then this one can just drop in, and we're under the press for insurance, but it looked like I didn't have to heat this up horrendously to get a slip fit. The bore of this thing is 27.99, and these things are 28, or this one at least is 28 point, yeah, they're both the same, 28.02. Yeah, they're all different sizes, they're not, I just looked at. So yes, that's the idea. So I'll bring this up to temperature, test it with that, and at that point I'll smarm this up with Loctite and then probably have to reheat this a little bit, and then hopefully it all goes smoothly. That's already a slip fit, so let's get the goo on here. Good to go. Just put a bit more heat back in this other thing. Alright, so I think we're good there. There's over. Glove on. Move that onto there. Get this in. Well, I'm certainly glad I had the press for backup. So I'll clean the excess Loctite off. That's retaining compound obviously, and that should be that. And it's good to see that just a little bit of the Loctite came out at the bottom. Not much. Yeah. So, thorough clean up all round. Alright, well that cleaned up nicely, and I reckon that liner is in there. I don't think that's going to be falling out. So moving on to the piston, I've got a blank in the lathe here, and I've put it in the collet block, so when I finish doing the turning operations I can move over to the milling machine with it. Unlike the Webster piston, this one is going to have a slight taper on the sides. In Greg's notes and recommendations, there should be more clearance for the piston crown than the skirt because it gets hotter, expands more. So what I'm going to do is turn a land here to the diameter that's required for the piston crown, and then I've got the top slide or compound set at a very slight angle, as you'll see. As I run the top slide back, and that is going to give me will cause the cutter to work harder up here than out here, so the piston crown diameter should fade out to the skirt diameter back here. Well, that's the plan. Let's see how well it works out. So I'll start by getting this tool dialed in. The OD here is 24.9, so let's get that set up. Alright, we'll take a light cut. We're not trying to take very much off here. The crown is only a little bit smaller than the skirt, so we're not taking much off. It should be enough to get a reading on what we're doing. So that's cutting at 24.87. So cut a bit more. We're trying to get to 24.81. I think I'm on 24.81 now, but I'm not getting a clean read again. Yeah, as I'm holding the calipers now, I'm getting 24.81. So I'm going to call that it. And you can barely see a step there. This taper really isn't much. Ideally, I'd like it to stop cutting or stop taking material just as it gets to the end. If it starts before it gets to the end, then this is on size. Yeah, I think what we'll do is go in slightly big and see where it runs out. So I was looking for 24.885. So I think I might try and take one more pass. So I think you saw that ran out all the way to the end. And we were looking for 24.885 on the end here. We finished up with 24.89. Well, so I guess that's within 0.005. I'm going to be happy with that. And I'll just check it up here as well. That's reading 24.80 there. I was looking for 24.81. Well, actually it's saying 24.81 now. So we're going to call that done. Okay, so to finish the outside turning operations on the lathe, I'll put the ring groove in now. The diameter at the bottom of the groove is to be 20.30. It could be 20.35, but I don't want it to be less than 20.30. I established that by making up a test piece and just checking the feel of the ring in the bore. And at 20.3 this thing will actually pretty much fall through under its own weight. So that's where the 20.3 dimension comes from. But I'm going to sneak up on that a bit anyway. So I go into 20.5 I think in the first instance. I changed my mind and decided to go in at 22. So let's come back to the other side of the groove. The builder's going bananas next door to me again. They are making progress, I'm pleased to report, so there may one day be an outbreak of peace. That's saying 2204. We'll keep going. This is 2.67. And that's a perfect fit. So the groove needs to be 0.03 wider and about 0.03 deeper. So let's see if we can make that happen. Right, what have we got for depth now? I think you better just see we're sitting on 20.3132, so I'm happy with that. The target was 20.30. So that's that. So let's see if we got the ring groove correct. That's 2.7. I'm going to call that 2.7. It's a bit snug, but that's good enough. Alright, so all that's left to do now is break those corners and the ring groove is done. That's a pretty snug fit on there. Alright, and there's a test fit. Yeah, that's got a lovely feel. It's engaging with the ring and moving it backwards and forwards a little bit in its groove, in the play that's got in the groove, because the ring's 2.4 and the groove's 2.7. So next step is to bore the bottom of the piston out. So we'll start off by making sure I've got my boring bar on centre, and I'm using a straight edge here pinned against the side of the surface, round surface. And I don't know whether you better see, but I've got it set so that the boring bar is ever so slightly above centre. So the top of this rule is just slightly towards me, ever so slight. But that just guarantees that the boring bar is not below centre, which over here would be a bad thing. But the sort of lightening feature at this end, hollowing out, is called out to be 22.2 diameter for 7.9. Getting close now, so I think this is, I'm not sure how many more cuts there are, one or two more perhaps. That Last one took me to 21, so I want 22.2, so I'm going to do this one at 21.6. So the previous cut I had set for 21.6 and it came up at 21.59. So I'll repeat it, the cut, but just move the setting to 21.6 now, and that should give us that dimension and a good surface finish. Well, that's the plan. Well, we've got a good surface finish. Then we finish up on the target size. So if I've got this right, we should be on 21.6. And dress rehearsal for the final run. Finished up on 21.61. Alright, so I need to leave myself a bigger margin. Okay, so in my previous pass, which I thought would be the last one, I finished up with 22.18, which is fine for the job. I mean, it's just a weight reducing thing, but just for pride, I want to try to get 22.2. So I'm going to do another pass with a depth of cut of 0.01, and we'll see what that does for me. Might mean I lose the shiny finish though, that's the only downside. Okay, let's see if that got me any closer to 22.2. $22.199. Oh, I'll go with that. I think it's pretty close. So, at the milling machine, ready to do the internal features. Basically, the internal feature that I've got to do is a pocket to accommodate the little end of the conrod. Now, as drawn by Greg on this, it shows that this slot would be 14 wide. But I discussed it with him, and he agreed that it probably didn't need to be that wide, and that 10, nominally 10, which is the width of or thickness of the conrod, plus a little bit for clearance would be appropriate. So as drawn, I would have made this by doing two 14 diameter holes with the centres 6 apart, which is pretty much how it's shown on the drawing. But I'm going to use a 10mm cutter, so to make sure that the outer edges of the slot are still at the same distance, i.e. 20mm apart, I have to do my two plunges 10mm apart instead of 8. Yeah, so anyway, what I'm going to do is, this is a slot drill, true slot drill, which will plunge cut. I'll do 3 plunges on centre and then 10 off, on centre and then 5 off to each side. So we made contact at 7.9. We go on down now to 20. Well, I'll go to 19, so I've got some to clean up from the bottom. That's 16. I thought I'd just get rid of some of this stuff and have a look, a bit of a think. Well, that pause and for contemplation, it was a good thing, because I realised that the ring groove which I've had to make to accommodate the ring that I was able to buy, that ring groove, the bottom of the groove, has a diameter of 20.3, or pretty much 20mm. So if I persist in putting a notch in here that's 20mm across, it's going to be just about breaking out into the ring groove. So that's not a good thing. I think what I'll do is I still have to do 3 plunges. The middle one of course hasn't changed, but I think instead of doing the outer ones set 10 apart to get a 20 wide thing, I'll set them 8 apart, and that will leave an extra millimetre at each end of the socket so I don't break into the ring groove. And if it turns out that I need more clearance for the angle of the conrod, I'll have to do that higher up. Anyway, that's my revised plan. That would have been nasty, breaking out into the ring groove. Alright, so you can see that slot came out alright. Unfortunately, it's not going to do the job. The width is fine, it's just a little bit of clearance as expected, but the length is not. The larger radius or the diameter of the 10mm cutter has not allowed the slot to progress far enough towards the outsides. So I'm going to have to do another pass using a smaller diameter cutter so I can get some extend the straight pieces on each side of the slot, make room for this. Okay, so I ran a 4mm cutter, oh you can just see them in the corner there, I ran a 4mm cutter around the corners and opened that out, and now we've got quite a good fit for that. So next thing is to turn this over, roll him over 90 degrees and drill the hole for the gudgeon pin or wrist pin. Okay, so we're set up now for drilling the hole for the wrist pin, but also Greg's documented an optional weight saving, or a couple of optional weight saving features to mill some non-critical areas of the piston. It takes some out of this part of the skirt that's not in line with the conrod. I don't think I'm going to bother with that. But the other one is to take a stripe across the end of the wrist pin hole, and I'll do that, not because I'm particularly worried about weight saving, but it just make it, the flat surface that results will make it easier to drill the hole for the wrist pin. So interpolating the design to the exact size of my piston, I've got to come down about 2.9mm, but I'm set for 2mm at the moment, and we'll see what it looks like after I've taken that. Now, I don't know whether I want to go the extra 0.5 or whatever it was, 0.95. Because obviously the deeper I go here, the less material there is to support the wrist pin. If I go the full depth, the wrist pin will have something like 4.4mm each side, which I suppose is adequate. Yeah, I'm in an R-ing here. So after a lot of agonising, I've decided I'll call that it. I won't do the extra millimetre. So I've turned it over, I'll cut the other recess and then drill the hole for the pin. Yeah, it just went through. Yes, makes my life a bit easier. Now the wrist pin is 6 diameter, so obviously we'll be putting an undersized drill through for that and then following it up with the reamer. But it's just occurred to me I might be advised to support this. Let's see if I can get some support under it. So I've put an adjustable parallel under there to make sure it doesn't move with the drill pressure. Right, so I've already made up the wrist pin, which is obviously a pretty simple turning operation. 6mm OD and a hole in each end for a rivet. I didn't have to make these, I actually had something left over from my dad's days when he was working on Lancaster bombers. These are the sorts of rivets they used apparently. Anyway, so it's got a 3.18 tail on it, or 1/8 of an inch tail, so I said 3mm before. I actually drilled it 1/8, so that'll be a push fit in there in due course. Now the wrist pin is supposed to be floating, and so a loose-ish fit in there, which it is, so that's good. So I think we're in business. Next thing is whether or not it all assembles with the conrod. So I think I can take it out of this vice setup now. This is going back in the lathe, so I can part it off to length. Then I think we'll have a finished piston. Couldn't help myself, had to make sure it all went together and worked the way it's supposed to. It does. Anyway, better get on and part the piston off to length. Well, it didn't come off quite as cleanly as I would have liked. It'd be nice if the nib was on the other piece, but anyway, just have to get that cleaned up now. I don't really want to try to take a facing cut across the full face here, because this piston does have a slight taper on it, and I'm not sure how square it's actually sitting in this chuck. So I'm just happy to clean the nib in the middle up, really. Well, that's a good place to stop. The boss just called me for dinner. Well, this isn't an easy thing particularly to photograph or film, but I'm really pleased with the way it turned out. The wrist pin is intended to float. It is held in place in the bore by the aluminium stoppers or rivets at each end to stop the steel from rubbing on the bore. The pocket in the underside of the piston to accommodate the little end bearing or little end of the conrod, that all worked out fine. And yeah, it's looking at it, it looks pretty simple. You think, well, how come it took you 2 days to make that? Yeah, I can't answer that, but it did. Well, when I review the work products from this video, we've got one piston and one cylinder liner, which doesn't seem like an awful lot. But I had to make 2 cylinder liners and 3 pistons, so there's a lot of work behind the scenes which I didn't include. But that's life. I'm an amateur, I make mistakes, and half the fun of it in some ways is working out how to recover from the mistakes. Anyway, there were some interesting machining challenges, and I hope you found it interesting and entertaining enough that you'll want to join me on the next video where I tackle the cylinder head. In any case, thanks for watching and cheers.